Hello, everyone, and welcome to today's webinar. My name is Liliana, and I will be the moderator today. Welcome back to those of you who have attended one or more of the recent webinars on project planning. Just a quick recap. We've done a series of project planning webinars where we cover a simplified way of project planning, which we call two-tier project planning. If you have not attended a webinar on project planning and would like more information on it, we encourage you to get in touch with us. I'll have my email address on the last slide of the presentation. The majority of you are already familiar with realization. For those who are not, here is a brief description. Realization was founded in 1999, and we have been at the leading edge of innovation in project management ever since. We were the first to introduce web-based project management. We also were the first to introduce multi-project management software and the first to embed critical chain method in our software. And the list goes on. We are proud of the bottom line results our customers have achieved. Among them, the U.S. Navy, the U.S. Air Force, and other branches of the Department of Defense, Delta Airlines, Lufthansa, Boeing, Siemens, and others. By finishing more projects faster in the last 17 years, our more than 300 customers have realized over $5 billion in hard savings. Our company and our clients have won many industry awards, including the Franz Edelman Award, Shingo Gold, and the U.S. Air Force Chief of Staff Excellence Award. Today we will cover a very important topic, multi-project management. We'll attempt to simplify it, and we hope that you'll take away a few important ideas that you can implement in your environment. Before introducing our speaker, I'd like to go over a few items. We'll record the webinar today, and we'll send you a link to the recording later, just in case you need to refer back to any of the slides or you'd like to share it with your team. The webinar slides are available for download from the Handout tab on your GoToWebinar control panel. You can ask questions at any time during the webinar. You can use Q&A section in the control panel. We promise we'll answer all your questions, and if we run out of time, we'll email you the answer later after the webinar has ended. I would now like to introduce today's presenter, Sanjeev Gupta. Sanjeev is the founder and CEO of Realization. Sanjeev.
Thank you, Liliana. So we will get started, and just to be sure, the focus of today is purely on multi-project management. So we know that even when we manage single projects, standalone single projects, there are many difficulties in managing those projects. And the primary difficulty is around the variability and the uncertainty, in the sense that everything about the project plan and its content and its scope can keep changing, which makes project management very difficult. So that is not what we are going to cover. What we will focus on is the multi-project management aspect of it, which is what are the additional difficulties that come in when you have multiple projects that are sharing resources, and combine that with the uncertainties that happen in the project. So first difficulty is that even if the world was very certain, everything could be predicted and you could plan projects very precisely and accurately, and nothing would change in execution. Even then, just the resource leveling problem, which is how do you level multiple resources across multiple projects, across the timeline, that is a very difficult problem to solve. But when you have uncertainties, now the interesting thing that begins to happen is that uncertainties of one project begin to affect other projects because of shared resources. So if your resources are held up on project one for a longer period of time because of any delays that happen on that project, that means any subsequent project that was waiting for those resources to get off and get those resources is now going to have to wait, and it will start getting delayed. And what that immediately leads to is a need for continual replanning. So whatever plan you create, not just at the single project level, but in terms of how do you manage resources across multiple projects, that plan also begins um, begins to change very often. And if those plans are not adjusted, or even if those plans are adjusted, there are going to be constant resource conflicts in execution, because just because you change the pipeline plan does not mean now the project manager has been relieved of delivering their project on time. So they are going to fight for resources that they need for their projects to be executed. And that immediately leads to multitasking, which is both at the individual level, switching between tasks, and at the organizational level, which is switching between different legs of the project or switching between projects. And the response to all these experiences from a project manager's perspective is they tend to overstate the resources they need, especially the highly skilled resources. And finally, in execution, the fear of a project manager is that if they give up resources too soon, or if the resources are sitting idle on their project and they let them go to a different project, they're not going to get those resources back. So they tend to hoard resources onto their project. And when it comes time to start a project, instead of waiting for the right date to start the project, they will tend to start the project as soon as possible in the hope of getting some resources from wherever they are in the organization. And all these behaviors amplify the multitasking issue that we talked about and cause much more harm to the projects. So how do we deal with this situation is what we are going to talk about. And the solution, for those who know critical chain and theory of constraint, this will not be surprising. For those of you who do not, the solution lies not in trying to manage variability, not in trying to be a slave to variability, but the solution is in exploiting variability. And what I mean by that is that instead of doing a bottom-up planning, you do top-down planning. Bottom-up planning would be that you have a detailed task schedule for every project. So you lay out a nice project plan, you lay out the task schedules, and then you try to move those tasks around from different projects to balance the overall pipeline. Versus, and the problem with this approach, of course, is that the task level schedules are going to change invariably in execution. So whatever plans you create is going to be gone out of the window as soon as you start execution. Instead of that, the trick lies in doing top-down planning, and I will explain that in the next few slides. But the idea is that you don't do a very detailed task schedule to create a pipeline plan. Similarly, instead of bottom-up planning in the sense of identifying specific resources, sometimes we have seen organizations, especially in engineering and product development, go down to individual names and assign individual names to the projects, even though the project has not started. And what we are saying is that instead of that, assign generic resources at the time of pipeline planning and assign specific resources as late as possible from an execution perspective. And I will clarify that point also. Finally, instead of trying to manage all resource contentions, instead of trying to level load every resource in planning, the idea in top-down planning is to level load based only on the constraints. And we will again talk about why that is a better way of doing things. Just a recap, what we have talked about is that a project plan, a good project plan, follows a two-tier structure. There is a higher level structure, which is tasks that determine the critical path of the project. These tasks tend to be longer tasks. And then you have subtasks and checklists, which are used by task managers or IPT leads in product development environments to manage their work locally. And we have covered this aspect in another webinar that Liliana alluded to. You can watch that. But the main point I want to make here is that when we are doing the pipeline planning, we are not using tier 2 tasks. We are using the tier 1 tasks for determining the pipeline plan. So when you do that, already you are taking complexity and variability, dampening variability somewhat, because you don't now have to worry about a lot of these subtasks and exactly what are the dependencies between these subtasks. when you create a pipeline plan. You create a pipeline plan at the task level, and these tasks are going to be much more stable, and it's much easier to deal with these tasks rather than the subtasks from a planning perspective. And the second concept I wanted to talk about was pipeline based on task schedules versus bucketized plans. And just a nomenclature here. I'm going to show you some illustrative project plans, very simplified ones though. The color of the border represents the project. The color of the task inside, which is the yellow color, represents the resource type. So here is the situation that you have a project. This is one project which has a blue project, which has some tasks that need to be done by the yellow resource and some tasks that need to be done by the blue resource. And when you have another project on top of it, so this is a nicely laid out schedule for the project along the timeline. And then another project comes along, which is the brown project. It also has needs for yellow resource and the blue resource. And now trying to fit these yellow resources and blue resources around the yellow and blue tasks in the previous project becomes a very difficult problem to solve. Do you take the first yellow task, for example, on the brown project and move it backwards, or do you take it and move it forwards? And what do you do if the space that you find doesn't fit exactly? Or what do you do with the space if the task is smaller than the space that exists in the pipeline? And this is like a Tetris problem, which is trying to fit exactly the various blocks, and it is impossible, we know that. More importantly, already in planning, if we try to do exact fitting, we begin to stretch the cycle times of the projects and still leave enough capacity that is unutilized, knowing fully well that the reality will be different anyway. So we go through this exact fitting, trying to optimize the resources, but we already in the planning process, we sub-optimize by stretching the cycle times, which means if you stretch cycle times, implication is now that more projects will be in execution and you will have more opportunities for multitasking, and you still leave capacity gaps in the plan. And as I said, the reality is going to be different anyway. So the solution lies in what we are calling the sand filling approach, which means instead of scheduling exact tasks, you schedule for capacity. So you can have, in this case, we have time buckets. We have divided the entire timeline into two buckets, just for illustration's sake. There's the time bucket 1, time bucket 2. And based on the number of resources and how many days a week these resources work, we can calculate the total amount of capacity that is available in each of these time buckets for the blue resource as well as the yellow resource. And now, instead of scheduling exact tasks, we are scheduling the workload coming from those tasks, or planning the workload coming from those tasks and fitting that into the bucket. So we are not trying to fit a task along a specific timeline. We're just trying to fill up the bucket with the workload from tasks from different projects that are during that timeline, during the time bucket. So obviously exact fitting is not needed. The cycle time stretch is now really negligible, because the worst that will happen is that the very last amount of workload that you try to fit into the first bucket does not fully fit in, and you have to shovel some of it into the next bucket. The capacity gaps are negligible. How much is the bucket size, whether it's a weekly bucket or a monthly bucket, is going to be dependent on your project and task durations. So for example, if you have a projects that are about 10 or 13 weeks long, then maybe you want to use weekly or even semi-weekly buckets. But if your projects are much longer, then you can live with weekly, semi-monthly, or even monthly buckets. And same thing with the task durations. The other important concept here is that as we do this, we want to leave aside some protective capacity to minimize the cascade effect. What I mean by protective capacity and the cascade effect is that if we have, for example, 100 hours of capacity available, we might want to say, 20 hours of that is protective capacity, which means we are not going to plan it. We are not going to fill that up. And in case a certain resource is held up on a project for a little bit longer than expected, then the delay will not cascade onto the next project because the next project has not been planned in that bucket anyway. So that begins to minimize the cascade effect. The important piece here, though, is that it's not as if you lose that capacity. In execution, when the reality is going to be different, and let's say you actually finish the project in first time bucket without consuming the protective capacity, you still have the flexibility of doing the next task. So you don't lose protective capacity, but it gives you enough cushion against the cascade effect. And same thing you can do in terms of reserve capacity for non-project work or drop-in work. The next part that I wanted to address was, which is very similar to detailed task scheduling in terms of its effect, is detailed resource scheduling, which is assigning very specific resources. So in this case, imagine that you have a software development environment and you have backend developers, 5 of them. Out of 5 of those, 3 of them can work on stack A, which is a stack of programming languages that they know how to program in, and 4 of them can work on stack B. And the specific people are Tom and Ashok and Chen, who can work on stack A. And then on stack B, you have Tom and Ashok and Monica and Bob. So you see that Tom and Ashok are multi-skilled resources. So if I now try to assign resources at the Tom and Ashok and Monica and Bob level in planning, you can already see how it is very similar to the Tetris problem. And moreover, it takes away all the flexibility that you naturally have in the organization when you get into execution. So again, the solution here is that, or the recommendation from our side is, go up as much as possible in terms of planning. In planning, the best place to plan is at the back-end developers level. Of course, when we get down to execution, we will deal with the complexity of which programmers can program in stack A and which programmers can program in stack B, but not earlier than that. Right? So really what we are saying is, at the time of pipeline planning, you deal with generic resources. When a project starts, so of course, all the resources might be flexible in theory, but in reality, when you start working on a project, you acquire knowledge specific to that project. And then it's not a wise idea to swap those resources in and out of different projects, because that is almost like multitasking. So you can assign a core team, which we will call project owners, just for nomenclature perspective. The people, the experts who are going to become experts in a specific project for the duration of the project, the project manager, the IPT leads. So that core team can be assigned to the project at the beginning of a project or a specific phase in the project, and the rest of the resources will be assigned to tasks at the time of execution. So this is the recommendation that we have, that try to follow this guideline as much as possible. And of course, there will be some exceptions to the rule, but this is the overall guideline. And of course, to assign resources at the task level, you need task level priorities that are normalized across projects. So you need a way to say which project needs resources today, or which project should be given priority today, in terms of, we have 5 of these developers available, which projects and which tasks they should work on. So you need a way of determining which tasks are more important. So far we have talked about the planning part. The piece that is also important, I'm not getting into execution side in terms of the best practices of execution, which is based on pull systems and Kanban and all those things. I'm just talking from a control perspective. Your reality, no matter how good a plan you create, no matter how much aggregation you try to do in the planning process, there is going to be some changes in reality in terms of resources. So either the resources that you thought were available are not available, or some projects got delayed. As a result of that, you might have bottlenecks in execution that are different from what you anticipated. You might have anticipated that my backend developers have a constraint, but in execution, the bottleneck can shift to UI resources, user interface resources. So it is very important to monitor the tasks that are there in front of every resource type, and the categories are tasks in queue and tasks in process. And so for example, if you have 4 developers, on a weekly basis, you want to monitor how many tasks were these 4 developers working on at any given time in the last week, and how many tasks that were sitting in the queue. And if this number starts increasing, so normally what will happen is that if there is a bottleneck, first the queue will start increasing. So you already know there is a bottleneck. And if you have not taken care of the bottleneck, then there will be pressure to multitask. So what will happen is 4 people will start working on 7 tasks or 8 tasks. So this is an early indicator without even, so what we are saying here is that when these emergent bottlenecks occur, it is important to take care of them, because every project that is going to go through this queue is going to suffer a delay. So a project that looks on time today, in 2 weeks, when it hits this resource, it's going to get delayed by whatever queue is in front of the project. So managing these bottlenecks gives you a much more advanced warning than monitoring project status, whether you do it through buffer management or through the critical path method. So this is an important aspect of multi-project management. And the final point I want to touch is that critical chain project management, from our experience, is valuable even in single projects, but it becomes even more valuable in multi-project management because of the idea of constraint-based planning. We talked about it, and the idea of time buffers and managing those buffers. And of course, the time buffers I will show you very quickly without getting into the nitty-gritty details of critical chain. What is time buffer and buffer management? So time buffer essentially is a block of time. In this case, the pinkish tasks that you see, they are the time buffers. So you have these tasks in the project, 6 tasks, which are of 5 days each in terms of duration, and then you have a time buffer of 15 days. And time buffer is an unscheduled block of time that is there to absorb delays from all the tasks that lie ahead of the time buffer. And the buffer management, what it means is, as we execute projects, we monitor how much time did it take to finish the tasks. And if instead of 15 days to finish 3 tasks, you ended up taking 22 days, that means you have consumed 7 days of the buffer. So the metric you monitor is how much buffer have you consumed versus how much project have you completed. And if you are consuming your buffer at a faster rate than the rate at which you are completing the project, your project is red, and the tasks feeding into that buffer are red. And otherwise, the project is green, and the tasks feeding into that buffer are green. And this becomes a very simple way to control the project, as well as to assign task priorities. So this is what we mean by time buffers and buffer management. So in critical chain project management, this becomes very much more valuable, because this gives you the tool to normalize task priorities across projects. And so in terms of the overall multi-project management process, this is just an illustrative process. The details will differ from organization to organization. But overall, what we are saying is you create tier 1 project plans. Tier 2 details can be populated as they become available later on. And tier 1 project plans means aggregated tasks and generic resources. Then you do pipelining based on constraints in capacity buckets rather than discrete tasks scheduled exactly on a timeline, with some protective capacity and reserve capacity. Then when you release the projects, you want to make sure that there are no bottlenecks in execution ahead of that project release. Capacity is available, and the core team that is needed for the project is also available. So you don't start a project until these 2 conditions are met from a resource management perspective. Then when you get into execution, then you do resource assignment across projects. So these are the resources, and this could be resources that actually do the work on the task. So like a drafter or an engineer who's actually performing the task, as well as manager and experts who are not assigned to a specific task, but who are the people who just respond to issues or problems that come up. So both for assigning the resources that work on the tasks, as well as prioritizing the time for managers and experts for problem solving, that is what is done in execution. And you do queue monitoring to identify emerging bottlenecks. So hopefully I have given enough solution to these problems that we talked about in terms of resource leveling being difficult. And what we are saying is by moving to less detail and more bucketized management of capacity, we make the resource leveling problem much simpler, and we also take advantage of variability. By providing for adequate protective capacity and time buffers, we manage the delays that cascade across projects. And because we have plans that are not very detailed, or the pipeline plan that is not very detailed, and you have enough buffer, that saves you the need for continual replanning. And having normalized task priorities gives you a way to manage resource constraints in execution. So with this, I would like to open up the, please ask any question that you might have. So I know we have covered probably a lot of ground, and I'm going to hand it over to Liliana, and then we will answer some questions.
Thank you, Sanjeev. We encourage you to submit your questions, and we'll be waiting for a minute or so for you to give you the chance to enter questions in the questions pane. And before it goes into answering questions, there is one question that says that I cannot download PDF file. We do not know the reason why, but we'll email you separately the file. And then there is another one that says that when I'm talking, there is an echo, and that might have to do with the IP over voice over IP phone that we're using, but we're not sure. We'll look into that, and we're sorry for that.
Okay, now I can answer the specific questions. One question is about how do you manage budgets across projects? So that's a great question, and it is a detailed enough topic that we are going to actually have a webinar on resource budgeting in a multi-project environment in a few weeks from now. But at a high level, if I may summarize, how do you manage resources across projects? The main idea is that you don't try to assign the time of specific resources to specific projects in execution. That is more or less a planning piece in terms of how much resources a project is going to consume and what it will cost us. So this is one general idea, and of course there are exceptions to it. And the second general idea is that you have to distinguish between fixed costs that the organization has versus the variable costs that are project specific. And the third idea is that you should always have an expediting budget in the project. And these are the concepts that I will cover in a later webinar, which is going to be exactly around budgeting and budget management in the projects. Another question here is around the roles. Okay, so there are two questions. One is the easiest way to monitor the task queue in front of a skill set. That is a great question. So obviously the easiest way, if you do not have a project management system, is to have some kind of a visual board that a resource manager maintains for their department or their resources. So they can have a list of tasks that are coming into the queue, and when they assign resources to the task, they can do that, and then they can bring that information to a review where all the resource managers and project managers can come in, which is typically an operations review kind of a meeting. So if you do not have a project management system, it can be manual. It can be done manually using the process I described. And if you have a software system, then it's a matter of just pulling out the reports, as long as people using the project management system to update what tasks they are working on. Because if people are not feeding that information in terms of what tasks have been completed and what they are working on, then you will not get information about tasks in queue or tasks in process. Another question, I cannot read the question fully. Are there any scenarios where it would make to have sense to have named resources all assigned? So the short answer is no. I have not seen a single scenario where that would make sense, unless you are a very small organization where you have only 3 or 4 people working on projects. Then most likely everyone possesses a different skill set, and having a skill set assigned to a project versus a person name assigned to a project is more or less the same thing. So that is one scenario. Or you have really some few engineers who are really experts and they possess unique skills. But even in those cases, what we have found is that those resources, you don't want to assign them to projects anyway. You want them to be separate from the project, available as expert resources to go and provide guidance and to go and do problem solving for people that are actually working on projects. Liliana, I need a favor from you. There is another question here where I cannot read it. I don't know if you can read it or not. Is this concept usable also in manufacturing? And I cannot read the rest of the question.
So the question, the full question, yes.
Yeah.
The full question is this concept usable also in manufacturing environment where people tend to exact planning, probably to do exact planning of the machines, and where is a huge number of orders?
Very good. Very good. So absolutely. Right. So so this is a great question. So this is a concept that is useful in all kinds of operations, which is you want to do top-down planning, not bottoms-up planning. Whether you are in manufacturing, where sometimes people get into the complexity of green machine versus blue machine, which is, I have a milling machine, but one machine is of a green color and the other machine is of a blue color. And you want to distinguish between the 2 types of machines in planning. You don't want to do that. Or, this particular machine has a dent, and I would really not like my part to be manufactured through a machine with a dent. And that kind of sophistication and detail in planning kills you right up front in the planning process. Not only does it make it complex, but it takes away all the flexibility you have. So it's useful in manufacturing. In an inventory management, supply chain kind of an environment, same thing. That if you take detailed forecasts from every store through which you are selling an item, or every location that is consuming the items, you are going to have a wrong solution. So you want to do top-down planning, not bottoms-up planning. So great question, and this is a general theme around all the good solutions which are in the theory of constraints, that detailed schedules, detailed plans never pan out in reality. There are 3 theorems in the theory of constraints, and this is one of the main theorems there.
Sanjeev?
Yes, please.
There is a second part or a second question to the question you've answered before about scenarios where it would make sense to have named resources allocated in project schedules. The question is, what if you have a dedicated team to one project?
Yes. So if you have a dedicated team to the project, from a planning perspective, the information that is available, really relevant, is the team. Is a team. I don't care about the specific named resources. That is a detailed information I can capture for reference. But from a planning perspective, it is the team that, or the pool or the crew. You have a situation in manufacturing types of projects where you are doing, for example, in shipbuilding or ship repair, where you have a crew of 5 or 6 or 7 people that is dedicated to a project. And the information you want to capture is not who is inside the crew, but that this crew is the resource that is been dedicated to this project. So at least that is my supposition, but I'm sure that there will be many scenarios that you might be grappling with on your end. So the best way to answer these questions is if you want to schedule a one-on-one time with me or any one of the experts, we can talk to you about the exact scenarios you are facing and see how we can implement the guideline in the best way possible in your environment. Okay, so actually there is just one more question that I want to answer quickly, and then any other questions you can submit. The question is about constraint-based pipelining, how exactly that works, and I guess the follow-on question might be, why is constraint-based pipelining enough to get you the best results? So yes, I should have probably spent more time on this in the webinar. You know what, let me just, instead of answering the question, because I need some visuals to explain this concept, so I will create a visual and we will have Liliana send it out to all the participants on constraints-based pipelining as to why that is a good solution. All right, so with that, my portion will come to an end. Thank you very much for attending it, and back to you, Liliana.
Thank you, Sanjeev, and thank you everyone for attending today's webinar. If you have any other questions, please contact us at the email address on the screen. We will send you a follow-up email with the link to view the recording as well as to download the slides. On behalf of Realization, thank you for joining us today and have a great rest of your day.